Lectins revisited.
All right, so good morning. My name's Dr. Paul Mason and I'm from Sydney. And today I'm going to talk to you about a protein that's found in plants called lectins and how they can have a massive impact on our health. And understanding lectins, I believe, fills in a massive chasm in conventional medicine when it comes to treating a myriad of chronic diseases. And certainly for me, understanding their impact has improved the care that I deliver to my patients. As with all of my lectures, nothing contained here within should constitute personal medical advice. So the story begins in 1976 in England, when 9 schoolboys ate some kidney beans that had been soaked but not boiled, and within 1.5 hours, all 9 of them ended up with profuse diarrhea and vomiting. And some of them had only consumed 4 kidney beans. And further illustrating the toxic potential of kidney beans is a diet containing only 1% kidney beans will kill a rat in 2 weeks. So the problem of uncooked kidney beans was considered so serious in England back in this period that the government started issuing written warning labels on uncooked kidney beans. So then that leaves us with the question, what on earth is in uncooked kidney beans that will do that? So this is a kidney bean plant here. It doesn't have any claws, it can't run away, so it's pretty defenceless. Well, you'd be wrong. It's not at the complete mercy of any caterpillar that wants to come along because it engages in some very potent chemical warfare. And the chemical warfare that plants use, one of them is called lectins. Each lectin is a protein with a unique structure, and it's a protein that has the ability to bind to carbohydrates. All of our cells in the body have these glycoproteins which protrude up from the cell membrane, and they contain a carbohydrate moiety on the end of it. And lectins can bind to that carbohydrate moiety, and that means lectins can therefore bind to our human cells. Now, what about reflux? We're all familiar with reflux. That's what happens when you have stomach acid in the stomach that ascends up the esophagus. It's often called heartburn. Well, you might be surprised to learn that lectins can also cause this because they can stimulate excess acid production. So this is a mast cell here, and it can secrete a chemical called histamine. And if it secretes histamine, that then leads to acid production in the stomach. And lectins can come along and bind to these molecules on the outside of the mast cell called Ig molecules, and that stimulates the histamine release. And through this mechanism, you can actually increase the acid. And this is one study where it showed a dramatic reduction in the acid levels in the esophagus within 6 days of starting a low-carbohydrate diet. And that's simply because when you go on a low-carb diet, you often cut out the lectin-rich grains and cereals. So they actually had probes down into the esophagus that were sitting there for 24 hours and measuring the acid level constantly. And you can see that in a matter of 6 days, there was a significant reduction in the acidity within the esophagus. And this is why symptoms of reflux often improve incredibly rapidly when we go on a plant-free diet. I'd like to make a very important point here. So far, I've only talked about plant lectins, but lectins actually do exist in animal foods as well, and other foods. The reason I'm only talking about plant lectins is that they're far more likely to be problematic. Doesn't mean that animal-based lectins can't be problematic, it's just they're so much less likely to do it. In this study here, this was a study looking at histamine release from 16 different lectins, and you can see the 4 that had the most significant response were all plant-based lectins. So that's why I'm tending to focus on them.
Just to give people a little bit of insight why I find it so fascinating is because he mentioned one part where these things, which were explained now what are lectins, they can actually cause Parkinson's. That was fascinating.
we'll turn our attention to a condition called Parkinson's disease. Now, this is a movement disorder. I'm sure you've all heard of it. You're familiar with it. You end up with a tremor. You end up with rigidity and slowed movement. And there's evidence now that this is caused by lectins. You see, if you ingest a lectin, and this sounds crazy, it can actually ascend up to the brain by travelling along nerves. And the nerve in particular is called the vagus nerve. So theoretically, if that was true, if you just simply cut the nerve, you would interrupt the highway which the lectins ascend to the brain, and you should be able to reduce the risk of Parkinson's disease. Makes sense, right? So they did it. So this is an example. This is a picture of the two vagus nerves, and when you cut them, it's called a vagotomy. So in one study, it was published in 2015, they compared every patient in Denmark who had this procedure between 1977 and 1995. And this is what they found. They found that by cutting the vagus nerves, the risk of developing Parkinson's disease dropped by 47%. Then, this is a more recent study that was able to actually confirm the mechanism. It was able to demonstrate that lectins were actually able to travel to the neurons in the brain which are affected in Parkinson's disease. And this graphic here shows the ingested P-lectin sitting on top of a neuron in the brain that makes dopamine. This is the problem in Parkinson's disease.
Fascinating. Makes me wonder if there is a connection between lectins and catatonia in autism. I know I have looked at it from the trauma response going into freeze triggered by stress, which is definitely true for me. But I remember when I had my first real catatonic shutdown of 30 minutes, just not being able to move. That was the real one, and back then, it was in 2007, I was a vegetarian and I had a very, very high consumption of beans, of rice, of tofu. This is all lectins when you think of it. And every single time after my meal, which is considered healthy, it was tofu, brown rice and some veggies. I had about 30 minutes where I would just sit there, felt so exhausted. I could not do anything. I had to digest that lectin heavy food. Interesting, isn't it? I'm sure there is a connection. And very shortly after that 30-minute catatonic state, I had that burnout, constant migraines and fibromyalgia, fatigue, depression even. And since then, I have not recovered from it, even though I became a carnivore, living out all of the plant foods, which removed chronic pain after 3 months, and after 1 month, depression was gone, brain fog was gone, and that stiffness I had in my muscles that was gone too, so it was definitely a game changer to remove all those trigger foods. But there are still issues which are trauma related, and they still get triggered through stress. And as long as there are so many outer stressors, environmental stressors, it is difficult to heal the gut. With everything I do, I have not yet succeeded so far. And for several months now, I have the burning mouth syndrome. So far, I have not found what works. It's stronger in the evening and less so in the morning, and after eating it is better. But it never goes away entirely, which is frustrating. But I know many other perimenopausal women who struggle with histamine issues actually have the same burning mouth syndrome. Yeah, so that's work in progress. But I stopped drinking coffee because coffee, it has sulfur and it has lectins. And I don't miss it. I never like the taste. Anyway. So that is that. I just think it's an interesting connection there.
Parkinson's disease, I mean, I probably threw that up there quite early on just to grab people's attention because it sounds so crazy. So basically, this chemical, if it gets absorbed across the intestinal wall, it can actually then go into a nerve called the vagus nerve and travel up to the brain. And it travels up to the brain that's affected in Parkinson's disease, and it can affect something called dopaminergic neurons and lead to a deficiency of dopamine, which is the underlying cause of Parkinson's. So if you think about it, you've got your stomach, then you've got the vagus nerve coming up from the stomach, extending up to the brain, and you've got this little lectin that can travel up, travel up this vagus nerve. And when I first heard this theory, I thought, oh man, that's crazy. There's no way. But then you have a look at the data, and it's really compelling. So, I mean, they did this Danish study where they got everybody who'd had a procedure where they actually cut these nerves, the vagus nerve, completely, because they're done for other reasons like trying to treat reflux and God knows what else. But they got everybody in Denmark who'd had that operation between 1972 and 1995, and they followed them up for about 35 years. And they compared them to a control group, and they compared the rates of Parkinson's disease. And they found that was a 47% reduction in Parkinson's disease if you'd actually had these nerves cut. And it's like, well, that's kind of supporting, but sort of doesn't really seal the deal for me for such a crazy theory. And then I went having a look at these animal studies, and they actually gave a P-lectin to dogs, and they did what they made it immunofluoresce. So basically they attached a molecule to it that makes it light up. And so you can actually see where this P-lectin goes. And then they gave it to these dogs, and then they euthanized the animals, and they had a look at the brains, and they were able to find this P-lectin was actually attached to the dopaminergic neurons in the brain. And these dogs developed Parkinson's disease. And then they did the same thing, but before they did that, they snipped the vagus nerve. And the dogs that had the same P-lectin, but without intact vagus nerve, they didn't get Parkinson's disease. So I was like, holy moly, these lectins.
So, what are lectins? There is the book by Stephen Gundry, The Plant Paradox, The Hidden Dangers in Healthy Foods That Cause Disease and Weight Gain. Most of us have heard of gluten, a protein found in wheat that causes widespread inflammation in the body. Americans spend billions of dollars on gluten-free diets in an effort to protect their health. But what if we've been missing the root of the problem? In The Plant Paradox, renowned cardiologist Dr. Stephen Gundry reveals that gluten is just one variety of a common and highly toxic plant-based protein called lectin. Lectins are found not only in grains like wheat but also in the gluten-free foods most of us commonly regard as healthy, including many fruits, vegetables, nuts, beans, and conventional dairy products. These proteins, which are found in the seeds, grains, skins, rinds, and leaves of plants, are designed by nature to protect them from predators, including humans. Once ingested, they incite a kind of chemical warfare in our bodies, causing inflammatory reactions that can lead to weight gain and serious health conditions. Dr. Gundry has successfully treated tens of thousands of patients suffering from autoimmune disorders, diabetes, leaky gut syndrome, heart disease, and neurodegenerative diseases, with a protocol that detoxes the cells, repairs the gut, and nourishes the body. Now, in The Plant Paradox, he shares this clinically proven program with readers around the world.
And we're going to be talking about the talk you gave at the Carnival Conference, which was about lectins.
Yeah.
And it was fascinating. Can you just explain to listeners what are lectins?
Yeah, well, fair question. So lectins is, I'm sure people have heard of Stephen Gundry. So he's sort of made a big deal about it with his book, The Plant Paradox. And it's based on the whole premise that there's these proteins that are mainly in plant foods that can bind to certain carbohydrates. So they're carbohydrate-binding proteins. And they can be absorbed across the gut through various mechanisms, usually related to leaky gut. And then when they get inside the body, then they do all kinds of mischief. So basically it's a protein that's found in a plant, not only in a plant, but the most deleterious ones are from plants. And they bind to proteins and they muck around. So I guess that's what a lectin is, the formal definition.
One of the most nutritionally important features of plant lectins is their ability to survive digestion by the gastrointestinal tract of consumers. This allows the lectins to bind to membrane glycosyl groups of the cells lining the digestive tract. As a result of this interaction, a series of harmful local and systemic reactions are triggered, placing this class of molecules as anti-nutritive and/or toxic substances. Locally, they can affect the turnover and loss of gut epithelial cells, damage the luminal membranes of the epithelium, interfere with nutrient digestion and absorption, stimulate shifts in the bacterial flora, and modulate the immune state of the digestive tract. Systemically, They can disrupt lipid, carbohydrate, and protein metabolism, promote enlargement and/or atrophy of key internal organs and tissues, and alter the hormonal and immunological status. Lectins are plant proteins that bind to carbohydrates and sugars on the surface of most of the cells in your body. Lectins are not part of the plant's good-for-you vitamins or minerals, and though they are technically proteins, they have absolutely no nutritional value. The problem with plant lectins is that your digestive enzymes can't properly degrade them. Not only that, but lectins also typically like to attack your gut epithelial cells, and those types of attacks can bring about effects that make it feel like you've experienced food poisoning. They can also cause damage to your immune system, digestive tract, and heart health when consumed in high amounts. Some of the acute effects that might occur after you ingest lectins are nausea, vomiting, diarrhea, bloating, gas. Furthermore, lectins prohibit your body's immune defenders from proliferating or growing. Yet another vote in favor of eliminating lectins from your diet.
General premise that lectins are harmful to us, I think, is that's well substantiated. So now I want to turn our attention to autoimmune disease. And in autoimmune disease, the body attacks its own tissues, and the particular tissues attacked determine what specific autoimmune disease it is. Because you've got a choice. There's heaps of them, more than you can poke a stick at. And different examples of them might include different types of inflammatory arthritis. You might have pernicious anemia. You might even have multiple sclerosis, type 1 diabetes, inflammatory bowel disease, lupus, and the list goes on. But the point is that all autoimmune diseases are characterised by the body's immune system attacking itself. And one of the defining features is called autoantibodies. So this Y-shaped structure here in the middle is what we call an antibody, and it's one of the main features of the immune system. And normally, antibodies are used to defend against foreign invaders, pathogens. If you have a bacteria, the antibody will have a strong affinity for the bacteria, and when it attaches to it, that then stimulates or initiates an immune response that will lead to the eventual destruction of that bacteria. And if this was a healthy cell here, well, hopefully that has no affinity for it. So on the surface of the cell here, you see what's called an antigen. That's a particular molecular identifying feature, either on a cell or a bacteria. And the specificity of that antigen and the receptor on the antibody will depend whether they bind together or not. And in the case of autoimmune diseases, antibodies have receptors that can actually bind to healthy cells, and then that can lead to your healthy tissues starting to be destroyed. And the presence of these autoantibodies is actually what I use to diagnose autoimmune diseases. It's one of the major things I use. And there's over 100 different antibodies that I can now test for back home in Australia when I'm trying to diagnose an autoimmune disease. Mm-hmm. And he's also, the main focus, I guess, in his book was autoimmune disease. Now, lectins are resistant to cooking. In the case of red kidney beans, it's recommended that you should soak them for 5 hours and then boil them for at least 10 minutes to reduce the lectins to a less dangerous level. And as well as being heat stable, lectins are often very, very resistant to the normal digestive enzymes that we have lining our gut. And it's to the point where a lot of lectins provide no nutritional value at all. They're often excreted completely unchanged. And often on the way through the intestinal tract, these unchanged lectins can often bind to the walls of our intestine and do significant damage, including killing the cells. So the way to think about it is our intestinal tract is a hollow tube from mouth to anus. And ideally, it should allow absorption of nutrients across the wall while not allowing entry of any toxins. And the lining of the intestinal tract has this basic structure. Firstly, there's a mucus layer on top, indicated in green here, and then beneath that you've got these epithelial cells which are joined together side by what are called tight junctions. And on top of the epithelial cells here, you'll see that little frill layer, and that's called microvilli. Now, on the very tip of these microvilli, we have something called a glycocalyx, and this has a glucose or a sugar or a carbohydrate component, which means that lectins can actually bind to this part of the intestinal membrane. So if we take something like wheat germ agglutinin, that will actually bind to the internal lining of our gut and damage it, and that causes something called leaky gut. Now, once you've got this single layer of cells, if you then fold it in a way, you can get these finger-like projections here, which we now call villi. And this is what villi look like under an electron microscope. Now, coming back to the general function of the gastrointestinal tract, if we had a toxin like a lectin, hopefully it would pass straight through us without being absorbed. But occasionally, we can ingest a toxin and we have leaky gut or intestinal permeability, which allows the toxin to actually enter the body. And this is a graph here that demonstrates the potential of these toxins, these lectins, to enter our body. So 7 participants consumed 200 grams of peanuts. And this test was actually measuring the amount of peanut lectin within their blood. And you can see that within half an hour the level started to rise, and within an hour there was a significant amount of this lectin seen in the circulation. And the ability, remember, of these lectins to bind to the surface of cells means that after entering our circulation, they can actually bind to cells in many different organs, depending on what particular affinity the lectin has for a particular kind of cell. So this image was done from a study that was done on females with unexplained fertility. And this is a sample of the endometrium, the lining of the uterus. And what you can actually see is indicated by the arrows, is they're actually demonstrating soybean agglutinin, a lectin actually bound to some endometrial tissue. Now, leaky gut, this intestinal permeability that allows lectins to enter into the circulation, is a key contributor to autoimmune disease. And gluten is one of the major causes of leaky gut. So about 80% of the total protein contained within wheat is gluten. And that's significant, not just from one fact, because it means that 80% of the protein is useless in wheat, so you're not getting as much protein as you think you are. But the gluten is also very damaging to the intestinal barrier. So this graph here demonstrates the intestinal barrier as assessed by something called transepithelial electrical resistance. The higher the line, the better. The top line shows barrier function in celiac intestinal cells that haven't been exposed to gluten. When we expose them to gluten, this happens. And you can see it happens rapidly within 15 minutes. And in people with celiac disease, this increase in intestinal permeability will persist for up to a week. But here's the thing that a lot of people don't know. It's not only celiacs who are affected by gluten. This top line here is non-celiac cells not exposed to gluten. This one here, non-celiac cells exposed to gluten. There's still a significant impediment to intestinal barrier function. Gluten impairs the intestinal barrier in everybody, not just celiacs. Now let's have a look exactly how gluten can do this. So the top layer in green here represents a mucus layer, and the bottom layer here in blue is something called the lamina propria. This is the tissue layer of the intestines where the immune system lives. You've got blood vessels and lymphatic vessels and a few other things kicking around there. And this here is gluten. Now, when it gets ingested, it can get broken down partially into these smaller parts called gliadin, but no further. And this gliadin then can bind to a special receptor called CXCR3. And once it binds to that, that leads to signalling within the cell that leads to the production of a molecule called zonulin. And this zonulin can then come and act on a receptor which leads to the breakdown of these proteins here called the tight junction or gap junction, which actually hold the cells together. And when that gets disrupted, the cells are able to physically separate. And this is what causes leaky gut. This is what leaky gut is. And then these lectins that have been ingested, as well as any bacteria that might exist in the intestines, can actually pass between the cells and get down to the lamina propria, where it gets exposed to the immune system and it's able to interact with the immune system. Now, because lectins are essentially foreign particles, we often mount an immune response to get them, so we often end up developing antibodies that will target them. So let's say here in purple that that's a lectin. And if you have a look at the antigen on the surface in green, you can see that it's the same as part of an antigen on a healthy cell. So that means if we develop an antibody response against the lectin, we can also develop an antibody response against a healthy cell. And this is called molecular mimicry. And this is thought to underpin most autoimmune disease. Now, lectins aren't the only cause of molecular mimicry in autoimmune disease. We can also have cell wall fragments from bacteria that look very similar to our healthy cells that will trigger this molecular mimicry type response. And certainly this has been shown to be the case in rheumatoid arthritis and a couple of other very specific inflammatory conditions. Now, in addition to molecular mimicry, these bacteria can also exacerbate symptoms of inflammatory conditions like arthritis because they secrete toxins called lipopolysaccharides. Now, you can see dotting the surface of the bacterium here and circled here what's called the lipopolysaccharides. And when the bacteria enter the circulation, they're then able to release these lipopolysaccharides into the circulation, which then will stimulate inflammation. And it stimulates inflammation because the lipopolysaccharide can bind to this receptor up here called the toll-like receptor 4, and that then initiates an inflammatory cascade, which ends up having a whole lot of deleterious downstream effects. But here's a key point, and I often hear people talking about the importance of lipopolysaccharides in inflammation, but they're not all the same. Some lipopolysaccharides will stimulate this toll-like receptor, and some won't. Some will block it. You can have pro-inflammatory lipopolysaccharides, and you can have anti-inflammatory ones as well. So, in general, lipopolysaccharide produced by this group of bacteria, the Bacteroidetes phylum, is actually quite inhibitory of this inflammatory cascade. And reassuringly, when we're in good health, it's this phylum of bacteria which produces most of our lipopolysaccharide. And further, if we're on a healthy diet, often a ketogenic diet, a high saturated fat and animal protein diet, those diets have actually been shown to increase the proportion of Bacteroidetes, which is actually falls within the phylum of the larger phylum that produces these anti-inflammatory lipopolysaccharides. So a healthy diet might actually increase the amount of lipopolysaccharides, but it will produce anti-inflammatory lipopolysaccharides. And this is a point that's often missed in the research.
Yeah.
I mean, the general concept of an autoimmune disease is that your immune system, which is meant to be knocking out pathogens, it's a case of mistaken identity, and they see the cells of their own body as being something they want to knock out. So the immune system starts to attack your own body. And the lectins can actually do that through a process called molecular mimicry. So if they get absorbed through the gut, and the immune system gets exposed to it, the immune system might want to go, oh, we don't like you. We're going to mount an immune response against you. But it doesn't mount an immune response against the whole lectin. They mount a response against something called an antigen, or a particular molecular signature. Just maybe a few amino acids long. Now, it just so happens that on some of those lectins, that molecular signature is the same molecular signature that you might see on a healthy human cell. Now, every cell is a bit different. A liver cell is different to a muscle cell and so on, which is why we have specificity for autoimmune diseases. So we have families, so you can have a thyroid autoimmune disease, you can have a muscle, you can have one affecting your kidneys, and so on and so forth. So you get these lectins, you generate a molecular mimicry response. Basically, these immune cells and antibodies that have learned to identify lectins as foreign, they'll now have a case of mistaken identity and they'll come after you. And I find that absolutely fascinating. And if you have a look at, we talked about celiac disease before, or gluten intolerance, and what was actually, celiac disease and type 1 diabetes, and we know that having celiac disease significantly increases the risk of type 1 diabetes, and vice versa. So autoimmune diseases come in families, and there's some really nice evidence too that the gluten is actually a driver of both processes. So if you get diagnosed with celiac disease, your risk of subsequently developing type 1 diabetes is far, far lower. And that's logical, because what's the first thing you do when you get diagnosed with celiac disease? You go on a gluten-free diet. So the driver of the disease, so gluten or gliadin is one of the main lectins driving the autoimmune process in diabetes. So eliminating that out of the diet will reduce the risk of transformation. And furthermore, they did this really elegant study in mothers, and they looked at what happened. They compared their gluten intake with the rate of development of type 1 diabetes in their offspring. And they found that compared to the group of mothers consuming the lowest level of gluten, the group that were consuming the highest, their offspring had double the risk of developing type 1 diabetes. So I think that's quite compelling to say, yeah, these autoimmune diseases, there is a link. The mechanisms are explained. We've got molecular mimicry, we've got the epidemiological data, we've even to an extent got some interventional data where they've actually looked at the rate of, say we take a biopsy of the kidney in somebody with a condition called glomerulonephritis, and they actually measure the level of antibodies, these circulating immune components, before and after a gluten-free diet. And what do you know? They fall. The tissue levels of the antibodies are far, far less once you simply cut wheat out of a diet.
Yeah. So again, I love it that people have these practical tips that if they are struggling with something, it makes sense just to give a gluten-free diet a go. But it's not just, don't just think about the gluten. There's all these other benefits that come with it. But now, you mentioned something about intestinal permeability earlier, the Swiss cheese where everything's got to line up.
Yeah.
So when we've seen it on the carnivore diet, when I've had different guests talk about that even their digestive system changes here. Do you think then someone who is more low carbohydrate or keto, that if they're still getting some sort of digestive systems, this potentially could be a reason they should test maybe for a period of time of trying to just minimize even that and going all meat for a period of time?
I mean, I guess the all-meat diet's been described as the ultimate elimination diet. I mean, I think that's a term frequently used. I mean, for my money, it's obviously hard to give any firm recommendations, but if anybody's having symptoms that are otherwise unexplained and they think that something they're eating might be causing it, well, I think you have to do an elimination diet as the most effective means of figuring out what that something is. And certainly, if it's a short-term period, I don't know of anybody who's ever been harmed by doing restricting plant foods for a short period.
Definitely in my case, I got my sense of agency back by removing those plant foods. Most of them, anyway. If I had continued to be on a vegan diet, I assure you, I would no longer be capable to walk or be without daily pain medication. I was totally going downhill, health-wise. That was in 2018. That was the worst year. So many health issues. Constant pain. Again, when I got up in the morning, I had to sit down instantly because my back was hurting so badly. And I had to wait until the pain was a bit less. And I couldn't stand for longer than 30 minutes at a time, and then I had to sit down or the pain would drive me crazy. So that was just the back, okay? And then I had constant migraines and fibromyalgia. So in addition to that, brain fog, digestive issues, and then there was the hip pain and stiffness and developing joint pain, and also blood sugar issues. Skin was super dry, bad wound healing, and so on. So definitely I can say it's still the best way of eating for me, even though I have other symptoms that are not resolved. It's still way more quality of life.
I'm just thinking of practical ways now that someone who's concerned that they've got leaky gut, that what I mean, other than going all meat then and reducing your exposure to lectins, would you have any others?
So my clinical approach is we can actually measure leaky gut. We can do a test. Basically, we give you two sugars. But there's several ways of doing it. One, you can use a molecule called polyethylene glycol. The other one is to give two sugars. You give a big sugar that's not normally absorbed, that should just go in the mouth and come out the other end. And you do a small sugar that should totally be absorbed. And then the small sugar that should be absorbed, if we take a urine sample 6 hours later, we should be able to detect it in the urine, but we shouldn't be able to detect the big sugar. And then if we detect this larger molecular sugar, then that tells me that the spaces between the cells lining your intestines has actually opened up and allowed this larger molecule to pass in. So that's actually quite a reasonable test for intestinal permeability. There's another one that I really like, is called fecal calprotectin, and that is derived from a cell, an inflammatory cell. It's a white blood cell called a neutrophil, but it's very specific for the intestine because it's a fecal sample we measure it in. And if that's elevated, then that gives me a strong clue, and it correlates really tightly with intestinal inflammation.
Just again, I'm finding this whole lectin world fascinating. It's just another element to when people are trying to problem solve and say, what is it exactly that's causing all my symptoms?
Well, it's given me a really good tool, because I'd see patients, I'm a clinician, and I'd come in and they'd say, I'm doing keto and I haven't lost any weight. I'd say, right, let's go through your food diary, count the carbs, have a look at this, do your bloods, how insulin resistant are you? And I mean, quite, not infrequently, so we can help most people, but we would draw up blanks with the standard paradigm. And what I'm seeing is that when we actually deal with the lectins, quite often, so I like to do antibody testing now, so these little antibodies which will be generated in autoimmune disease, they're the main way that we actually use to diagnose autoimmune diseases. And I can test for over 100 different antibodies. Get the pathology manual out, I can just flip through it to my heart's content. It's fantastic. And the most common antibodies I detect are against the thyroid, which would be consistent with a condition called Hashimoto's thyroiditis. And if I see these antibodies, so what I'm finding is that people who come in with these sluggish types of metabolism, their TSH, their T3, their T4 might be absolutely fine. Even their reverse will be absolutely fine. But once we see the presence of antibodies, it's like, you need to go on a lectin-free diet. And then we see the benefits. So for me, you talk about the problem solving, it's just given me another string to my bow. This was what was missing from my clinical practice. And having this in my arsenal, being able to test for intestinal permeability and being able to test for the presence of antibodies and a lot of these what we call subclinical autoimmune diseases, which just really means that they're not so overt that we can diagnose them. But I don't really believe they're subclinical because patients are feeling symptoms, but they're just sort of vague enough and non-specific enough that we can't diagnose it. Mm-hmm. But certainly I think that if you want to establish if you have an issue, so you can do a fecal calprotectin, you can do an intestinal permeability test, and you might either want to do a what we call a PEG 400 or a polyethylene glycol, and 400 just refers to the size of the particles, or a double sugar method. There's a couple of different sugars you can use, as I described before. You can also, in some labs, get something called a serum zonulin, which means the chemical zonulin in the blood. And this is actually probably really relevant. Now, we haven't touched on it yet, but the mechanism of leaky gut. Zonulin actually plays a big role in that. And zonulin is a chemical that gets released when by two main stimuli, by inflammatory stimuli and by gliadin, or one of the components of gluten. And that will directly stimulate the release of zonulin, and zonulin will come and basically destroy these proteins holding the cells together. And that's the main cause of leaky gut. So if we can detect zonulin at higher levels, that's also quite a useful test. And I think one of the key points here about autoimmune diseases is that almost all of them have increased intestinal permeability at their heart. So I came across a genome-wide analysis study that placed inflammatory bowel disease at the centre. So that's a prototypical inflammatory intestinal permeability condition. It contains Crohn's disease and ulcerative colitis. And what they actually found, so you've got this disease in the centre, and in this genome-wide association study, you've got all these folks coming out to 23 other different conditions, most of them which were other autoimmune diseases. So it really just shows you how tightly linked. If you have inflammatory bowel disease, your risk of having, 23 other conditions was also increased. And in my mind, I would put forth that increased risk relates significantly to the increase in intestinal permeability, and that is what actually allows the lectins to then access the immune system, and you can get this molecular mimicry response, and your tissues are starting to be targeted by your own immune system.
And I mean, IBS, or irritable bowel syndrome, is so prevalent out there and goes both from constipation to diarrhea, and people, they struggle with it. They think, is it just psychological? Is it this?
Well,
is it
IBS,
that?
so we have to distinguish between inflammatory bowel disease, IBD, and IBS.
Okay.
And the easy way to distinguish between that would be to do a fecal calprotectin or an intestinal permeability. We can also do a test for what we call fecal reducing sugars. So irritable bowel syndrome, I think, is more of a condition where you have some carbohydrates especially, but also sugar alcohols, which don't get absorbed by your intestines, and instead they track down to the distal part of your colon, where the bacteria in the colon can ferment them. And as a part of that fermentation process, they produce gas. And some of that gas may be methane, which actually reduces the movement of the wall. The fact is that you get a bit of bulking out, can sometimes lead to feelings of constipation, especially if the gas is produced early in the small intestine. Then it's not able to wind through the wall and escape easily, so you feel really bloated, like you need to pass something, so you have sensations of constipation. But because they're what we call osmotically active molecules, little sugar molecules, they actually attract fluid to them as well, so they give you watery stool, and that really explains why you get these mixed symptoms of constipation and diarrhea, which on the face of it doesn't make a lot of sense. You sort of think, well, aren't they mutually exclusive? It should be one or the other. But no, if you actually understand the mechanisms, you can actually have this sense of constipation and slowing of the what we call peristaltic motion, the muscular contractions, at the same time that you've got liquid stool. Now, unfortunately, the consumption of lectins in our diet is actually increasing significantly. So, in part, this is due to natural selection, selective breeding, and genetic modification of crops, which tends to select for species that are naturally resistant to pesticides. And that natural resistance comes from lectins. So let's take a look at the specific health consequences that these lectins can have, beginning with obesity. Has anybody ever noticed that when they cut plant foods out of their diets, that they lost weight? Even if you're already on a low carbohydrate diet. So why is that? I know several people who have lost over 10 kilograms, and it's because lectins can stimulate the insulin receptor. Insulin is a hormone that stimulates fat storage, and lectins can stimulate this. This graph here is from a 1983 study, and it compared active fat storage between wheat germ agglutinin and insulin. So down the bottom here, this is what happened to fat storage when insulin alone was given. This is what happened to fat storage when insulin plus a lectin in the form of wheat germ agglutinin was given. And this is what happened when you just give lectin alone. And the point is that it stimulates the insulin receptor in a far more prolonged fashion than even does insulin. So this is a concern if you're trying to lose weight. But it's not only wheat germ agglutinin that has this ability. In the same study, they actually looked at 2 other lectins as well. And you can see ability to produce persistent lipogenesis, creating fat. And it seems like lectin can also impact on another hormone critical to fat storage. And this hormone is leptin with a P, not to be confused with lectin. And the hormone leptin is essential in regulating appetite, satiety, and energy balance. Have a look at these 2 mice. The one on the left has no leptin, demonstrates the importance of leptin functioning effectively. And lectins, with a C, can actually bind to the leptin receptor and interfere with it, causing resistance. And this here is a study showing of another lectin, concavenin A, that leads to leptin resistance. And when we test this in animal studies using isochloric diets that simply eliminate lectins, it leads to significant weight loss in the animals.
Which plant foods have lectins?
In fact, there's over 100 known sources of plant lectins, and many of these are toxic to humans.
Nightshade vegetables are some of the worst lectin offenders out there. These consist of the following plant foods: potatoes, eggplants, tomatoes, tomatillos, goji berries, ground cherries, ashwagandha, bell peppers, jalapeno, chili peppers, curry powders, chili and cayenne powder, and paprika powder. Then you have the lectins in grain, barley, quinoa, wheat, rye, brown rice, buckwheat, oat, corn, and the nuts and legumes: peanuts, cashews, chia, pumpkin, lentils, and the beans: azuki bean, mung bean, kidney bean, soybean, black turtle bean, pinto bean, and so on. Chickpeas, edamame, peas, and pea protein. Tobacco.
Genetics plays a huge role in these conditions. And in actual fact, I like to think of it, I used to work in occupational health, and when an accident happens, we always say, well, what defence was there against that accident happening? Say if somebody fell over, was there water on the floor? Was the lighting bad? Did they have slippery shoes on? Were they tired? So we have layers of defences. And with regards to autoimmune diseases or Parkinson's disease, for instance, that requires you to have the wrong genes. It requires you to also have lectins in the diet, and it requires you to have an increased intestinal permeability, otherwise known as leaky gut, so those lectins can actually be absorbed in your body. So if you think about you've got 3 layers, think about like 3 layers of paper, and they've got a hole in the middle of each paper. You'll only have the accident happen if all of those holes line up. If you only have two deficiencies in the defences, you might be eating peas and you might have leaky gut, but you don't have that genetic susceptibility, then probably you're not going to get that. So it's certainly what we call a multifactorial condition.
Do all plants have lectins?
So I guess I don't know for sure. I couldn't say for sure, but I do know that there's over 119 plants that have been identified with lectins. Paul Tom, then that's a minimum. So probably there's plants without lectins, but I wouldn't know what they are. There's certainly some lower lectin plants. So if you listen to Stephen Gundry, there's a few plants that he tends to recommend as being low in lectins. I don't know if he ever uses the term devoid of lectins, so don't know exactly whether they're very rich in lectins. The lectins are often concentrated in the seeds of these and in the skin. And that makes a lot of sense if you think about them evolutionarily from a plant point of view, because they don't want to be eaten. So they want to protect the reproductive parts of the plants, which is why they're often concentrated in the seeds. So some of the strategies that you can do is you peel your vegetables, de-seed them, and then make sure you cook them. In most cases, that will actually reduce the lectin levels significantly.
So the preparation.
Multiple case studies and reports of that in the medical literature. So the recommended method for reducing kidney bean lectins to a safe level, or just reducing it, not eliminating it, is to soak them for 5 hours and then to boil them vigorously for at least 10 minutes. But there is a bit of a caveat with that, and that's a bit of an aside, but some studies have shown that if you just heat them up to 80 degrees rather than boiling them, then that could actually potentiate the effect of the lectins within them by about 5 times. So you really, it's almost Russian roulette with kidney beans.
So anyone who's out there and loves their kidney beans,
it's most kind of beans. So you look at castor beans, we don't eat them, and there's a good reason, because that's where you get ricin from. That's a nerve agent, a nerve toxin. They use it, it's been used militarily in the past. But in general, as a rule of thumb, beans and legumes are lectin rich. Now, some of them have worse and more harmful lectins than others. But for my money, I don't eat them.
Okay. And do you get different types of lectins then?
Yeah. So because the lectin's a protein that binds to a carbohydrate, and it binds with a lot of specificity. So it's not going to bind to everything it comes across. Now, the reason it's important, we probably should say, with a human cell, you've got on the outer membrane of it, you've got these little glycoproteins. So it's called glyco because it's got sugar in it. So a little protein with a little carbohydrate, a sugar cap. And they're very specific. And certain lectins will be able to bind to the glycoprotein on certain cells. So if we have a look at wheat germ agglutinin, for instance, that will bind to the glycoproteins that line the blood vessels and damage that. If we have a look at P-lectin, then obviously from the study we talked about with Parkinson's disease, that's got a strong affinity for dopaminergic neurons. So they must have the glycoprotein on those neurons must have a good affinity for P-lectin. So yeah, they're very specific, and they cause different conditions. And incredibly beneficial when you actually come up with something, and especially when you know what to do about it. So previously, if we had a diagnosed leaky gut, we probably would have been a bit vague about exactly what we do. And now we sort of, well, there's avoid this, there's this supplement, you can do this. We know that there's several factors, so there's certain things you should avoid. So a supplement, like you can actually supplement with lecithin, because that's actually got phosphatidylcholine in it, which makes up about 70% of the mass of the mucus lining the gut. So if you take that, that can actually help restore the mucus membrane that protects the cells.
What is phosphatidylcholine and how is it used? So apparently it's also good for cognition, liver health, gallstones even. Interesting. What is it? Phosphatidylcholine is a phospholipid attached to a choline particle. Phospholipids contain fatty acids, glycerol, and phosphorus. The phosphorus part of the phospholipid substance, the lecithin, is made up of PC. For this reason, the terms phosphatidylcholine and lecithin are often used interchangeably, although they're different. Foods that contain lecithin are the best dietary sources of PC, although PC is traditionally used to support brain health. It can also support liver function. PC supplementation can increase the neurotransmitter acetylcholine in the brain. It may also improve memory. It may help dissolve gallstones. That's also interesting. So that's a core MedScience site. Phosphatidylcholine benefits for brain, liver, gut, and cellular function. One of choline's main roles in the body is brain and nervous system function. Choline gives rise to the neurotransmitter acetylcholine. In the brain, ACH controls our ability to focus and retain information. Outside of the brain, ACH is the main communicator of messages in our conscious and unconscious or autonomic nervous system. The conscious nervous system uses ACH for things like a voluntary muscle contraction, while the autonomic nervous system ANS regulates all of our organ functions like heart rate, blood pressure, breathing, sweating, gut motility, kidney and bladder function, among others. In addition, how quickly we think and react has to do with the speed of nerve electrical signal transmission. Choline is also used to manufacture sphingomyelin, a component of the myelin sheet surrounding nerve cells, a fatty envelope responsible for speeding up the transmission of nerve signals. Without sphingomyelin, nerve signals would travel much more slowly. Myelin becomes damaged in multiple sclerosis, causing decreased processing speed, muscle weakness, loss of balance, and generalized fatigue. It's not surprising that low levels of PC and choline lead to acetylcholine and sphingomyelin depletion. This leaves us feeling lethargic, unable to focus, and weak due to muscle fatigue. Adequate levels of choline are also required for proper cognition. Food sources of phosphatidylcholine. For the carnivores, it is beef and fish, eggs, dairy. So, good to know. My body only accepts camel milk. And I definitely can say there are a lot of benefits. Exosomes are extracellular nanovesicles that play a role in cellular trafficking and communication. Camel milk exosomes might carry the potential of recovery of several illnesses. That coins the dromedary milk.
We've got these diagnostic tools now, and now we've got these interventional tools. So as a clinician, it feels wonderful for me to be able to say, I've done the objective test, you now need to stop eating this, this, and this. These are some lifestyle factors, avoid the processed foods, pollution, and sometimes it's as simple as we've got people who live in a busy city and we've got a nice running path near us. It's right on the edge of a busy road. And it's like, maybe you shouldn't run on that path during peak hour traffic, because we know that pollution that you're going to get from some of the diesel vehicles is going to make it worse. And so it's all these little lifestyle factors and supplemental factors that make the incremental differences, and people feel good.
Yeah. I mean, yeah, that must be just so rewarding. And as you said, it's just, you've got another tool in your toolkit there, and it's unlocked a whole new level for these patients who feel stuck and they're like, I thought I was doing it all right. I just don't know what's going on.
I don't know if you know much about chronic fatigue syndrome, and I say that sort of a bit tongue-in-cheek because nobody knows much about it. It's always been one of those conditions where we try and, we hypothesize it's the latest evidence is it's actually autoimmune. And a lot of people who come in and they'll have symptoms that would be consistent with a classical diagnosis of chronic fatigue syndrome will get better when you deal with the lectin side of it. So, it's for a clinician, because they're the kind of patients, and look, I don't know if I should be saying this, but doctors, we have what we call heart sync patients. And we call it heart sync because they walk in the room and your heart syncs. And it's not meant to be pejorative with a reflection of the patient's personality or anything like that, but it's the kind of patient who, as doctors, we genuinely want to help people. And we get frustrated when we can't. I mean, obviously it affects the patients more, but I mean, hopefully we're in this for the right reason. We want to make people better. And there's a couple of common presentations that traditionally are heart sync presentations, because fibromyalgia would be another one as on top of chronic fatigue that traditionally we just can't fix. And for me, I'm actually really enjoying these patients now because I feel that I can offer them some hope. And it doesn't mean that you fix all of them, but the number of them that have significant benefits makes it all worthwhile.
Yeah, and that's the reward again, that you were able to find something to help that person who was just in this stuck place for so long. Yeah.
I mean, I honestly think this is a whole new frontier in medicine, and I can't wait to see what research is done in the next 5 or 10 years. But it's quite exciting to sort of feel like you're at the cusp of the cusp of something new. When you see the impact, when you look at the impact that lectins can have on insulin receptors and stuff like that, you can say, well, it can't be just about the carbs, and it's not. Because if it was just about the carbs, there'd be no difference in weight loss on a vegetarian low carb diet and a plant-free low carb diet, and clearly there is. People lose massive amounts of weight when they reduce their plant foods, when they reduce certain plant foods.
And this would also be of the calories in, calories out, so you could be having the same amount of calories on these two different diets, but it's still this, maybe the lectins is the issue.
Yeah, so what it does, it changes energy balance. So, I mean, calories in, calories out, you can't get away from that. You cannot lose weight unless you burn more energy than you take in. That's a fact. But the calories in, calories out model, unfortunately, doesn't tell you how do you actually get your body to burn more than you're putting in. And this fits perfectly in with that, because if it's creating a leptin resistance or activation of insulin pathways, then that explains why that's why you're going to be storing fat. It stops you burning fat. It makes you feel hungry. It explains both elements of the calories in, calories out. It tells you why you're putting too much in it. It tells you why you're not burning enough. So rather than just trying a descriptive model, let's go for an explanatory model. And, if we understand the role of insulin, and carbohydrates has a big role in that, I'm not saying it doesn't, but I'm saying that we shouldn't deny the role of lectins in that process.